Now base 2 and base 16 are common bases, not nearly as common as base 10, but they're still common. But we can do this because of the pattern is exactly the same. We can do this with any base, bases that are not used at all. So let's do a base 7, which nobody uses, right? But we can identify what digits are allowed. The digits would be 0 to 1 less than 7, which is 6. So those are the allowed digits. And we can identify the place values for this, right? So the place values are going to be, we always start with the ones place on the far right. So that's 7 to 0 is the one place, and 7 to 1. So this is really straightforward to do with any base number. And you can figure out those place values. Once you have the place values figured out, then you can do what is called the decimal expansion of the numbers. And another way to say this is you're converting it from whatever base it is to base 10. So something that we can work with. We really don't have, there's not much that we can do. Oops, I'm not getting that. I'm trying to talk and do this at the same time. Doesn't work so well. Okay, so we can do this with any base that we want to work with. And then to do the decimal expansion is you use these place values. So let's do a decimal expansion of a base 2 number. So base 2 number would look something like this, except it wouldn't be all superscripted. Okay, so that would be a base 2 number. So let me go ahead and put these all in the places where they are, right? So I'm just going to expand it each to be in the place value. And I could do that. Oh, let me go back and show you. This is really important. How do we tell that that is not place 10? In fact, we can't. This is 10,110. That's that number. If I want this to be a base 2 number, I have to say it. With base 10, I don't have to say it, but with every other base, I need to either put a subscript that says the base, or I need to say it in parentheses, base 2. Because otherwise it's just a base 10 number. So now that I've made it a base 2 number, really important to put that subscript on. I can go ahead and do the expansion, the decimal expansion, so convert it to a decimal number. And the way that I do that, again, is to work with these place values, right? And so this is going to be a base 2 number, and each of them are in their specific place. So let's go ahead and we can write this up. This is 1 times 2 to the 4. Now, I'm not going to write it out. Well, I'll write it out the first time, but after that, I'm not going to write it out because it just takes a long time to write it when I can do it you can often do it in your head. So we have 1 times 2 to the 4th, right? 2 to the 4th. And then you do the plus. And then it's a 0, right? You do the digit, 0 times 2 to the 3rd. And then plus 1. And you get the idea of how you write this out. 2 to the 2. Now, when we're doing this, oops. And this is why I'm not going to do this very often, because writing it out just takes a great deal of time. And then it's 1 times 2 to the 1. And this is a 0 times 2 to the 0. Okay, this is the base 10 expansion. Because what we're doing here is we're going to convert it to base 10. When we do these calculations, our calculations will be base 10 calculations. So when we do 2 to the 4th, right, that's 4 times 2 times 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 1 times 16, which is 16, plus 0 times 2 to the 3rd, which is 0, plus 1 times 2 to the squared to 4. And so that is 4 plus 0 times 2 to the 0. Okay, so now we've written these values in base 10. These are base 10 numbers. And we've expanded it using the place values and converted it to decimal. So now we add that up and the value is 20. So what this is saying that the binary number, base 2, is equal to 20. And 20 is base 10 because it doesn't specify any subscript. So that we just converted a decimal, the base 2 number to a base 10 number.